So I've got the homework for 3.4, domestic electricity. And the first one is electric heater. It's got the following label. So I've underlined that straight away, just in case. But we can see it uses 8 hours. So I'm already thinking hours, cost, it must be that the only equation that we use with kilowatts and hours. Because most of the time, power is watts, that would be normal, and time would be seconds. But in this case, because we're dealing with cost, it's going to be kilowatt hours, kilowatts, and hours. So use the information and the equations. The information is by here, and the equation on page 2. Page 2, you're going to get given a formula sheet to work out in pence the cost of 1 unit of electricity. So we got 4 marks available for this. So let's have a look. We've got this formula. Nope, I can't make that bigger. So I'm looking at kilowatt hours, kilowatts, and time hours there. And then, so you've got 2 equations. First, I'm going to have to find out the units, and then I'm going to have to find out the cost. So cost per unit it wants there. And then I've put, so 8 hours in 2 weeks. So every day for 8 hours for 2 weeks. So 2 weeks, there's 14 days in 2 weeks. 14 days, 2 weeks equal 14 days. So that's why I've times 8 by 14 to give me 112 hours, first of all. Okay, so I got my hours there now. I got my units used equals power times time. That I've got from this formula sheet. So my 1.5, I've already converted 1500 watts into 1.5 kilowatts. Remember, if you're going from small to big, then you're going to divide. And that gives me 168 units. Now it wants to calculate the cost in pence of 1 kilowatt. So I've used £25.20 in total. So I kind of need to rearrange that equation. So this, we're already starting off with a big equation here. Remember, if you've got cost units and cost per unit, to do a triangle, you can just chuck cost up the top. If units are already with cost per unit, it's just like any other triangle you use. So I've done one there, look, cost is on top, because cost is this side. You've got units times cost per unit. They need to stay together on the bottom. So I've got cost on top. Now I know my cost is £25.20. And I know my units. I don't know my cost per unit. So cost per unit now, if I put my finger over that on my thumb, it's going to be cost over units. And the cost is 2,520, because obviously I've got to convert that to pence. That's over 168 units. And that gives me 15 pence a unit. So straight in with a tough one there. But not impossible. Not impossible by any means. Use an equation from page 2 to calculate the number of joules now of electricity. So we're looking at joules converted to heat and light in this 2-week period. So let's have a look. Have I got one for joules? Yes, I have. It's energy. We should know energy equals power times time. So it's essentially the same equation, really, but instead of energy, they're using units used here, using kilowatt hours. But power times time is exactly the same as power times time there. So it's all energy. This time it's in joules. If we're reverting to joules, then we need to come back to seconds for time, and we need to come back to watts for power. So I've got here, I'm saying, convert 112 hours into seconds. To do that, if I've got 112, well, I know there's 60 minutes in an hour. So I need to times that now. So we're going from big to small now, so I'm timesing. So 112 times 60 times 60, because it's 60 seconds in a minute. So that's why I've times it by 60 twice. And it come out to be 403,200 seconds. Big number, which is why you can see that they use these hours and kilowatt hours up here. Then I've got energy equals power times time. So now my power is 1500 from up here. I'm not going to use the kilowatts. I'm just going to leave it as watts and then times my seconds there. And that gives me this massive number, 604,008,000 joules. Or I've said 604,000 kilojoules there. But it wants it in joules, so I'm going to leave it as this one. 2 marks there. This one then, a bit of a numeracy problem. You're just looking to find the pattern, fill in the blanks. Use the information given about the kettle and the food mix to complete the table. So there's space for work-ins there. So we've said, there's my units used, power times time there. I've rearranged that to get my power for this one because I didn't know this one. But I do know how many hours and I know how many units is used. Okay, so by putting in the number of hours, which is 1.5 there, and how many units was used, I can get 2 kilowatts for the power. And obviously to convert that to watts then, if I go from big to small, I need to multiply. Okay, 2000 watts there. So that's where I got those two from. And then this one is a bit of an easier equation because you don't have to rearrange. It's units used, power times time. So I've got, from the table there, I've got 5 minutes. And I've got 0.72. So 0.72 I can work with because it's kilowatts. It's already in kilowatts. But this 5 minutes is difficult because it's not in hours. So I need to find out now how many 5 minutes is in 60 minutes, if you know what I mean. So 5 into 60 is going to give me 0.83 hours. 0.83 hours. 0.83, I don't think that's right. Oh, hang on. It's 0.083. I've missed one there. Yes, I thought that wasn't right because that's closer to an hour there. That is actually closer to an hour, and it's like 5 minutes. It's nowhere near an hour. So it's going to be 0.083. I'm going to try and put that in. So that's 0.083. I haven't got my pen on me. Charging. So this now is going to come out to be 0.06. Yeah. How did I do that? I missed that. So this one here is 0.083. And the answer does come out to be 0.06. I've probably done it in my calculator, but didn't write it out properly. I would have lost a mark there. So out of 5 marks, I probably would have got 4 marks for missing that 0 there. Still come out with the right answer. So again, it's so important to show your work-ins. Okay? Because even if I messed up that answer and come out to be 0.6, I could have still carried marks on. I could have still got 4 out of 5. And on a higher paper, you know, there are some serious marks there. Some serious marks. Anyway. This next question, and then I'll probably do a part 2. A householder left home for 14-day holiday. To deter burglars, she left 5 filament lamps, timed to come on for 5 hours a night. Each lamp is worth 100 watts. Okay. Calculate the total electrical power of the lamps in kilowatts. So I've got 5 filament lamps, all at 100 watts. Now I need to take the 100 watts to a kilowatt. So I divide by 1,000 and it gives me 5 times 0.1 because this is 0.1. And that gives me the total power there for 5 of those is 0.5 kilowatts. This is obviously from a foundation paper now. Use equations, number of units equals power times time. It's already given me the kilowatts and hours, so I know I've got to work in that. To calculate the number of units of electricity for 14-day holiday. Well, it says there 5 hours for 14 days. So every day was 5 hours, so it's 5 times 14 with a power of 0.5, which is just calculated. Okay, so that is 0.5 times 70. So 5 times 14 is 70. And that gives me 35 kilowatt hours. That's my units. And then I'm going to carry that down now to calculate the cost. So cost equals units used times cost. The cost is 8 pence. So 35 times 8 is going to give me 280 pence. Keep it in pence because the unit there they've already given you. Don't convert that to £2.80. And then a 20-watt low-energy lamp produces the same amount of light as the 100-watt filament lamp. Give a reason why the cost would be less if the filament lamp were replaced by 20-watt lamps. Well, I've said there's less energy, so less number of units used. You would actually use instead of 100 watts, you're using 20 watts for the same amount of time. You're going to use less units. Yeah. Calculate the savings of the householder. Now, when it says savings, you're going to be minusing one from the other probably. So let's have a look. Calculate the savings of 20 watt lamp we used instead of the filament lamp. So let's work it out for the 20 watt one. So you can do it two ways really. You can either go and work it all out again and then deduct one from the other, or I've recognized here that 20 watts is 1/5 of the 100 watts. Yeah, 20 watts goes into 105 times, so it's 1/5 of the cost there. So 20 over 100 is 1/5 of the cost. So 1/5 of the cost, which is 280 pence, would be 56 pence. Yeah, so I'm saving 280 minus 65 pence because it wants the saving. So I've got a saving of 224, and I've said that should be up there. So I'm probably going to leave that there and then do another video part 2. So I'm just going to write there to remind myself. So part 2 is going to be there.